We're going to be talking about my new for me setup for my neural network. So, in the past, I've talked about the fishbowl neural network idea, and this is a name that I've given it. I don't know if it's out there already being used in some sense, but and then and so what I've done is I've begun the coding process, I believe for the third time, but I just keep restarting and trying to perfect the actual concept of it before I get into the nitty gritty of actually implementing it. So I want to show you kind of the design of this, and I have talked about the fishbowl neural network in the past. I'll probably put a link up to a previous talk so you can get an idea of the actual concept behind it. But essentially, it's something that takes in analog inputs, or sorry, binary inputs, and spits out binary outputs. And what is special about it is it's not necessarily your normal setup for neural networks. So it's not your normal progression through the layers. The idea is that these connections can be to any different node. So you can go backwards, you can go forwards, and the beauty of this is it actually allows the AI to set up its own logic. So the AI can create sort of a computer that is built to either hold information, process information, or react fairly quickly based off of some instinctual measure. So um, that is the idea. There's some interesting concepts. I'll go through a couple of them just real quick. Um, I mentioned that the AI will be able to hold on to information, and the way that it can do this is so let's say we have these nodes in this kind of pattern, and so this is our input, this is our output, and we have a loop like so. Well, what this can do is so the way that this works is say this one is ready to fire. So this one is highlighted. So it has a connection to this node here. The way that it does this, so it can fire, and when it does fire, it flips all of its connections. So these nodes can either be a one or a negative one. Negative one is off, one is on. Now I could do 0 or 1. The reason that I'm doing this is it's fairly easy to flip the current value just by multiplying by -1. So that's important. Um, so when this node fires, it will ignite this node. So then this node will fire, ignite this one, and when they ignite, they turn themselves off. So we're gonna put a big slash through there, um, and so then this one fires, ignites this node. I think you get the pattern, so I'm just gonna kind of skip ahead. So here is where it's gonna get interesting. So we're gonna cross that guy out, and so for here, this node is going to have two different connections, like so. So what it's doing is it's feeding the information that it currently has on, but it's also feeding this information into this loop, like so. And when it gets back to here, then if this node is no longer firing, then this loop will perpetually continually push that information on. Now, what can happen is if this node fires again at the same time that this guy right here fires, then this node will be flipped on and then off, ending the loop. So there's some possible logic here, and I think that's a fairly interesting concept. Now, I won't necessarily be able to visualize this. I was hoping that I would be able to set it up in some sort of visual representation so that it would be nice to see these firing. But because there's going to be a lot of randomness as to where specific nodes are connected. I didn't think that the visual representation would actually give us any big insight. It would just kind of be there, taking up space. So I wanted to focus on getting the actual logic down, implementing it into what I'm planning to just implement it flatline into the environment project to see if that will actually amplify the results of that. But it may be a situation, because of the way it's set up, where I need to run it in a game where it just has to go in a straight line, and then run it in a game where it has to spin around and line up with a target, and then combine those activities into a situation where it has to go and turn in the process. And because of the way it's set up, it will have this structure, this data structure set up so that it can be moved from one task to the other and still have the previous data structure to work with. But I think that I'm going to focus on the just letting it loose on the previous task and seeing if it works well, and that's where we're going to go. So let me get into the actual structure that I am thinking of for the code itself. So first off, we have our fishbowl neural network, right? And so what we're going to do is this is the neural network, and it's going to be running some simulation inside. So this is going to be our sim. This is going to be our fishbowl neural network. And so this is some loop inside here that is constantly running the game that it's playing. And it's taking in inputs, feeding it through its own system, and spitting out outputs that will create decisions in the game, whether it goes straight, whether it turns on a flashlight, something like that. And so then we're going to have this outer loop from here that's going to be somewhat larger. So in this outer loop, there is going to be a secondary feature here. So this is going to be the mutation. So this mutation is an evolutionary system. So if you've seen way back when, an evolutionary system is actually a system where it tries new traits, and if those traits produce a better result than the previous traits, then those propagate onto the next generation. Now, this won't necessarily be genetic in a sense, because I'm not necessarily kind of. It's going to be a singular parent genetic, so there won't be two possible points where it's creating mutations from. These mutations will all be based off the current situation and just trying to make tiny tweaks to it. So it will be allowed to make a certain amount of changes, and those changes will have probabilities based off of it will have probabilities to decide which ones are actually going to are going to be changes. So then we need to decide what those numbers are going to be. So the probabilities of specific changes, whether they be creating a new connection, deleting an old connection, creating a new node, something like that. We need to decide which of these, what are going to be those values. So what I decided that what was going to happen is there's going to be a larger loop outside of here, and this is going to be a regular classical neural network. Now it will be so it's not necessarily a neural network. It's steepest descent optimization. So this is going to be our value optimization. And the reason that this is important is because An evolutionary system is actually quite inefficient. It will try a lot of the same things over and over and over again. And the reason that I want to have this system is because I don't know what the best values are for how many mutations should happen every generation, how many different changes it should try, and what kind of changes are important. And that might be a dynamic question. It's not necessarily something that I can set values for right at the beginning and just allow it to run free and it will just work until it's perfect. And there's a lot of things in AI where if you don't set it up correctly, it will reach exhaustion at a point you're not necessarily satisfied with. So I want there to be this option for when it is not necessarily making as much progress, it can try to change the way that it's making progress. And that's what this value optimization is for. It's going to be changing these possible mutations and the probability of those mutations happening. So what it can change is sorry, I have it up on my whiteboard over here, so I might be looking back there. It can change the number of mutations, not an H, a pound sign. The number of mutations. It can change the probabilities of those mutations. So I'm going to put a percentage times 3, I guess, because there's the adding a connection, deleting a connection, and adding a node. I don't want it to be able to delete nodes. I think that would be detrimental. It could just reuse those nodes by adding or deleting. So I think that the more nodes available, the more potential for actual propagation of logic. I'm seeing a question: what kickstarted your fascination with AI? I kind of had it on my mind just in general. I mean, AI is pretty cool as a concept, but one thing that really kind of got me interested was I actually watched Seth Bling's coverage of there was a team that made an AI for Mario, and I believe it was like mar.io. And what they did was they made a neural network that actually would just live in the Mario world, in the two-dimensional old Mario 64 world. And what it would do is it was getting rewards from picking up coins and jumping on Goombas and stuff. And it basically learned how to survive in the world, not necessarily playing the game, but just kind of surviving. And I think that kind of propagates into what I'm focused on now. Is I want to create something that can sort of just receive a fitness score and create its own goals and go explore new possible ways to play in an environment that I set up. So I think that is a lot of the inspiration that I got. So this is kind of the setup. I had a lot more loops in this before, and then I ended up dwindling it down to just this propagation. Now, there is still 3 loops. There's the simulation cycles, and those cycle through the actual fishbowl neural network. This is much like if we had a regular neural network. It would be using that to make decisions in real time. And then these mutations are happening in the background. So it'll be testing new ideas. The way that it's going to do this is actually going to split off, and so the first half of this, per se, is going to be testing the old ideas. So this is going to be the old ones. And then in the second half of the cycle, it's going to test the new ideas. And so it's going to, it's going to test each change and see if that makes a benefit. Well, that's not necessarily true. So it may be better to test a bunch of changes at once. In an evolutionary system, you usually allow it to create a bunch of mutations and then go check to see if those mutations were beneficial. The problem with this is it can allow for propagation of negative mutations, but hopefully later on those mutations will be worked out of the way because better ideas will come along. Now, this also kind of brings up the possibility that the AI could regress to a worse state. Say the AI was really good at going straight in a straight line, and it gets some new idea that it can uh, I don't know, it knows how to turn the flashlight on now, but if it learns how to turn on the flashlight at the expense of going straight, that could be detrimental. But that's something I'm hoping will work itself out in a little bit. But I kind of want to get it running first before I start tweaking things. So it tests the old version to get a datum in the current situation, because in real time, you may have Jeffrey here, and maybe there's a rock here, and there's a piece of food on the other side, and Jeffrey wants his score to go up. So in this current situation, it will test the old instincts to see um, if that creates a benefit in score, and then it will also then after that it will take whatever the last score it had with the old one and use that as a datum for testing the new one. And so I'm not actually testing based off of raw score. I'm testing off of improvement. So I want the AI to be trying to learn how to make its score go up at the highest rate. I think that's a better idea because of the way that the game's set up. I'm trying to, what am I thinking? Um, Motivate exploration. So I want the AI to go further. And if you have seen any of the Environment Project videos, you will know that there is in the fitness score, the AI earns a higher score if it leaves its home position and goes further out into the environment. Although once it's out in its environment, it starts losing battery. Um, so that is the situation. But the AI won't necessarily know what its score is. It I'm trying to think of how I'm going to implement it. So with binary inputs, I can't necessarily just feed it raw the its health score and its battery score. But what I can do is I can feed them in as binary numbers. And with exponential um, growth in binary, it would be a decent string of numbers, but it wouldn't be that much. So if the highest health is 100, then let's see, you can get a 64 and a 32, and that'll bring you to 96, and then you just need four more. So you would have 1 4, 132, and 164. That's three ones. Um, so maybe if like the 64 category is a zero, then that's a problem because a good chunk of the battery is gone. But if the 32 is a zero, that's not necessarily as much of a problem unless the 64 is also gone. So I think that's an interesting way to implement it, and I'm going to see how it works out. But I have had problems in the past with AI sifting through data. Now, there won't necessarily be as much data because I'm boiling everything down into binary inputs. So hopefully it won't be nearly as much of a problem as when I were, say, implementing the site feature in Sell Me Something, because I was in Sell Me Something, the AI could see its surroundings, but when I implemented it with a very large radius for that, one, it slowed down the game tremendously, so that was problematic. But two, the AI couldn't necessarily figure out how to navigate because it was looking at too much. So one thing that I'm planning to do with Jeffrey here is there's a couple things that Jeffrey had in the environment project, and so the environment. Let me clear the screen. We'll kind of just talk about that for a little bit. So Jeffrey had two things he could do in the environment project. Oh, two. I don't know where I got two from. So he has his radar, He has his flashlight. He has his sprint. And then he has like move times 4. Oh, well, no, it's actually just move times 1, and then rotate. So, with these situations, now rotate we might have times 2 or something like that, just because we want him to be able to move in either direction, um, as opposed to having to turn all the way around to get into the direction that he wants. Um, so with the radar will let you know if something is on the screen. So it's wide range, but it's not very intuitive. It's not very intelligent. So it just gives you an idea if something's there. So there's something. Now the flashlight is more enlightening. No pun intended. Well, pun intended actually. It's local, so it's a local area around Jeffrey, but it tells you what's there. So I'm working out um, how to categorize this. So specific. I'm thinking that what I will do is set up sort of a bundle of inputs that have to do specifically with the radar and the flashlight. And also, what I'm thinking is I'm going to boil this down to 8 things. So if there's more than 8 things on the screen, Jeffrey won't necessarily know about that ninth thing. Um, and what I'm going to use as the deciding factor of what is known and what isn't is proximity. So Jeffrey will focus on the things that are close to him, just so we're not getting too much data in. So with this flashlight bundle of inputs, you will have maybe um, a option of the possible things that it could be. So it could be food, it could be an obstruction, or it could be an enemy. Those are pretty much the only 3 things that you can have in the environment project. And so whichever one it is will just have a big, it'll have a positive one there as opposed to a negative one. Um, and then it will also have the proximity. So the proximity will have to be something that is a string of binary numbers, well, one binary number, but it will be a string of either negative ones or ones, to decipher what that number actually is. And obviously, it will have to be brought to an integer. Um, and then we also have to give the direction. Now, the direction is going to be a little bit trickier. I may be able to do binary with actual degrees, and that could be what we want. But that might get a little too complex. I'm worried about that being too complex because um, if we have something like, let's say, if we're talking in binary, then we have like 32 degrees, and then we have 96 degrees. Both of those fire the 32 bit or byte, or I don't know which one's the actual just small one, but they so if Jeffrey were to be making a decision based specifically off of the 32, and not the 64, then there's a big difference between 96 degrees and 32. The hope is that eventually all of these will be accounted for, and that's not a problem. But it's going to take a lot of logic, and so I'm curious to see how it actually plays out. I kind of want to make it too complex to begin with, just to see if this system can handle it, and then try and boil it down to an easier input. Because part of the problem with a survival in an environment is actually the assets you have at your disposal. And since Jeffrey can't necessarily change what assets he has other than turning them on and off. Um, he can't he can't make he can't necessarily improve himself in that situation. He can only use his assets better. So if I give him something that is a poor asset, then that's not that's on me. That's not on the actual program itself. So um, yeah, I think that's how it's going to be done. Is that the information is going to be put in? So there'll be like 8 chunks of this, which will probably all be negative ones until there's actually 8 things on the screen. And then for the radar, it'll probably be the same thing. There'll be 8 of those. And Jeffrey will be able to focus on those 8 things. So with the radar, you won't need this first section. So that won't be necessary because all Jeffrey needs to know, there'll just be one there that there's something there. Either that or you don't even need that because all of these will be some different value. They won't propagate. If that's actually yeah no, so there needs to be one node that specifically says there's something here, because if these are zeros, that's the same as saying that something's right on top of him, and that could be problematic if he were making decisions based off that. So that's pretty much where we're getting at. I think that's pretty much all I want to talk about for the fishbowl neural network project. I'm planning on working on that significantly more in the days to come. I'm not going to make any promises on how soon that will be out, but I have made significant progress on the actual coding of that, so I'll keep you guys updated on that. So I need to switch over, and we're going to do the actual random drawing section.